Hello everyone, welcome back. We have a friction problem in front of us and it reads, a body of mass 9 kilograms resting on a rough plane inclined at 30 degrees to the horizontal is about to move up the plane. What is the frictional force required to prevent motion if a force of 60 newtons is applied parallel and up the plane? Take G is equal to 10 meters per second squared. Solution. The first thing we'll try to do is to draw a diagram for this. So this is the diagram. We have a body of mass 9 kilograms that is resting on a rough plane inclined at 30 degrees to the horizontal. So theta will be 30 degrees. It says the body is about to move up the plane. So the direction is up the plane, right? We are asked to find the frictional force that is required to prevent this motion. So what we first have to do is let's try to indicate the forces that are involved. We have a force that will always act down the plane, which is mg sine theta. And since the body is about to move up the plane, it means that the frictional force will have to act down the plane in the opposite direction, right? So we're going to have friction F acting this way. The applied force is 60 newtons and is up the plane. That is the direction of the applied force. Okay, so that is P, the applied force is 60 newtons. Now let's try to indicate the remaining forces. One of them is the normal reaction, R, and the other one is the weight of the object. That is going to come vertically downward. So the question we're going to ask ourselves is, what is the state of motion of this body? When a body is about to move, that is called limiting equilibrium. Okay? This is not acceleration, but limiting equilibrium. So if a body is in limiting equilibrium, we know that the opposing forces must be equal in magnitude. So, which means the applied force, P, must be equal to the frictional force and mg sine theta. Okay? In a state of limiting equilibrium, the opposing forces along the plane must balance each other. But in acceleration, that balance will not exist. One of the forces must be greater than the opposing force. So with acceleration, you have a net force. So since acceleration has not been mentioned in the problem, it means that we are dealing with limiting equilibrium. And from the statement itself, just about to move means that the body is in limiting equilibrium. So if we have that, we want to find the frictional force, we can say P minus mg sine theta is equal to F. Therefore, F is equal to P minus mg sine theta. This is what we want to find, the magnitude of the frictional force, okay, to prevent motion of the plane. So since the body is about to move up the plane, the frictional force have to act in the opposite direction. Remember that. So we'll say F is equal to the magnitude of P, that is the applied force, is 60 newtons, minus the mass is 9 kilograms, so that will be 9 times gravity is 10 and sine 30. So that will be F is equal to 60 minus 90 sine 30. So F is equal to 60 minus 90 sine 30 is 45. So the frictional force will be 15 newtons. Okay. So 15 newtons has to be applied in the opposite direction to the direction of motion so that motion can be prevented up the plane. Moving on to the second question. We have a problem here that reads, a body of mass 8 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the body and the plane is 1/5 root 3. If the body moves up the plane from rest, what is the magnitude of the acceleration if question 1, no external force is applied? Question 2, if a force of 88 newtons is applied parallel and up the plane. So here we are dealing with motion up the plane. Okay, we have two cases. The first case is when there is no applied force. The second case is when there is an applied force of 88 newtons. So we will begin by answering the first case, when there is no applied force. But first, let's try to bring in the diagram. So this is the diagram. We have a body of mass 8 kilograms that is resting on a rough plane inclined at 30 degrees to the horizontal. So let's try to bring in the forces that are involved. We have a force that is always acting downwards, which is mg sine theta. Okay, and if the body is going to move up the plane, that is the direction is up, the frictional force have to act in the opposite direction, that is it will be down. Okay, so if we want to complete the diagram with the other forces involved, we have the normal reaction R, and we have the weight coming vertically downwards, W. Okay, so to remind you, the body is about to move up the plane. Okay, but there is no applied force. So if there is no applied force, it means that the two forces that we have are all acting in the opposite direction to the direction of motion, which are F, that is the frictional force, and mg sine theta. Since we are asked to find the acceleration, we need to know the net force. Okay, we know that we do not have any force, okay, or any applied force up the plane, so that is going to be 0. So how do we find the net force? Remember, the direction of motion is up the plane, so the net force we said is equal to ma. So what will be the net force? The upward force is 0 minus the downward force. We have mg sine theta plus F. Okay, they are acting in the same direction. That must be equal to ma. So that will be minus into mg sine theta plus F is what? Mu r. So this will be equal to ma. So we're going to have minus mg sine theta plus mu, what is r? R is mg cos theta. So this is equal to ma. So if we want, we can factorize m out. Okay, so that will be minus m into g sine theta plus mu g cos theta. This is equal to ma. So m will cancel m. We're going to have minus into g sine theta plus mu g cos theta is equal to a. Okay, so therefore acceleration is equal to minus g sine theta plus mu g cos theta. The negative sign tells us that for a body that is moving up an inclined plane without an applied force, that body is actually decelerating. Okay, it is not accelerating, but instead it is decelerating. So if we substitute, we're going to have a is equal to minus g is 10 sine 30 plus, what is the coefficient of friction? The coefficient of friction is 1 over 5 root 3. That is the same as root 3 over 5, right? So that is what we're going to write. The coefficient of friction is root 3 over 5 times gravity is 10 cos of 30. So we'll have a is equal to minus, what is 10 sine 30? 10 sine 30 is 5. Then plus 5 goes once here is 2 times. So you're going to have 2 cos 30 multiplied by root 3. Okay, so that is supposed to give you 3. Okay, so therefore acceleration is equal to minus 5 plus 3 is 8. So that will be minus 8 meters per second squared. Okay, so that is the answer to the first question. We are asked to find the acceleration when there is no external force. What you have to be reminded of is that if a body is moving up the plane without an external force, that body is actually in deceleration. So that is why we have that negative sign there. All right. So the second question is, we want to find the acceleration if the applied force is 88 newtons. That is question 2. The first thing we have to do is, let's bring the diagram. Okay, this is the diagram. Still, we have the body of mass 8 kilograms. And let's try to bring in the forces that are associated with it. The body is moving up, remember. The friction will be in the opposite direction. That is, it will act down the plane together with mg sine theta. The mg sine theta is always acting downwards, whatever the case. Okay, so for this case, because the body is moving up, friction has to act in the opposite direction, that is down the plane. And here we are given the applied force as 88 newtons, that is up the plane. Okay, we have 88 newtons. So we want to determine the acceleration. For there to be acceleration, it means that the force that is acting upward must be greater than the forces that are acting downwards. Otherwise, the body will not go up the plane with acceleration. It makes sense, right? So we want to find the net force. The net force must be equal to MA. So what will be the net force? We'll have P, the applied force, minus the downward forces are F plus mg sine theta. So this will be equal to MA. So we'll have P minus, what is F? F is mu r. So plus mg sine theta. This is equal to MA. So that will be P minus mu, what is r? R is mg cos theta plus mg sine theta. This is equal to MA. If we substitute the values, we're going to have P, which is 88 newtons, minus what is mu. We said that is root 3 divided by 5, multiplied by the mass is 8, multiplied by gravity is 10, cos 30 plus the mass is 8 kilograms, multiplied by gravity is 10, sine 30, that is equal to the mass is 8 multiplied by A, acceleration. So that's going to be 88 minus, so 5 goes once here is 2 times. We're going to have 16 cos 30 multiplied by root 3. Do that. 16 cos 30 multiplied by root 3 will give you 24 plus 8 times 10 is 80. So what is 80 sine 30? That is 40. So that is equal to 8 times A is 8A. So what do we have? We're going to have 88 minus, what is 24 plus 40? That is 64. This is equal to 8A. So 88 minus 64 is equal to 8A. What is that? 88 minus 64 is 24. So that is equals to 8A. To find A, you divide both sides by 8. So which means the acceleration will be 3 meters per second squared. Okay, it is positive here. Why is it positive? Because there is an applied force that actually causes an acceleration of the plane. Thank you very much for watching this video. Please subscribe to the channel, like and share our videos.